Hello guys, welcome back to STEM Trainers. Now in the previous video we have seen how to solve moment questions. So we have basically seen that if a rigid body is in equilibrium, the net forces in any direction is zero and net moment about any point is also zero. And we have solved a couple of questions on it. So let's move further. Now today we are going to see center of mass questions. So basically for uniform rods and non-uniform rods. So for uniform rods, the center of mass is always at the midpoint. And if the rod is non-uniform, then center of mass may be at midpoint or may not be. It depends on the rod. Okay, so let's try some questions to understand this more. So we have this first question. A non-uniform rod AB of length 5 and mass 15 kg rest horizontally suspended by the ceiling from the ceiling by two vertical strings attached to C and D, where AC is this, AD is this. Given that center of mass is at this point, find the magnitude of tensions in the strings. Okay, so let's make a rough diagram for this. So we have a rod AB. So let's take this point as A, this is B. Now this is suspended from the ceiling by two vertical strings. Okay. At point C and D. So this is C, let's take this point as D. Now it's given that AC is 1 meter, so this is 1 meter. AD is 3.5, so obviously this will be 2.5 CD. Given that center of mass is at E, where AE is 3. So somewhere here between C and D, there is a point E which acts as center of mass. So basically we can assume the whole mass of the rod is acting at this point, which is actually how much? 15. So this is 15G. So this will be tension, let's say TC. Let's take this as tension TD. So these are all the forces. Now what they are asking is we have to find the magnitude of tensions. And it is given that this is in equilibrium. Okay, rests horizontally. It means it is at equilibrium. So now, so first thing that we are going to do is when it is at equilibrium, we can say that TC plus TD, that is sum of net forces acting on this rod will be 0. So TC plus TD will be equal to 15G. So upward force total will be equal to downward force total. So that's one equation. Now second equation we can form using moment, right? So we have discussed this. You can find moment about any point, and it's always convenient to find moment at either C or D, because in that way moment for one tension will be 0, right? So let's find moment about C and let's see what happens. You can find moment about D also, you can find moment about A or B also, it doesn't matter. Okay, so it's always convenient if you find at C and D. So what will happen? So moment for tension C will be 0, right? And moment of tension at D, so TD will be equal to, into its distance will be 2.5, and this will be the direction. What's the direction of this? This is important, right? We discussed moment has a direction also. So this is the force, this is my point C, so it will go like this, and this direction is nothing but anti-clockwise, and we have discussed anti-clockwise we will take as negative. So minus TD times 2.5. So we will take clockwise as positive. You can mention that also while you are solving, that taking clockwise movement as positive and taking anti-clockwise as negative. What else is there? Okay, 15G is there, and this 15G will be, okay, so this will be clockwise, right? This is the force, this is the direction. So this will be clockwise. So plus 15G into distance. What is this distance? This total is 3. So this distance CE is nothing but 2 meters. So 15G into 2 equal to 0. Net movement will be 0 about point C. So from this is already 0. So we can say that TD times 2.5 should be equal to 30G, right? 15G into 2 is 30. And from this, we are getting tension at D to be equal to 30G divided by 2.5. So which is nothing but 12G. And let's substitute the value of G. So we are getting the tension as 118 newtons, up to 3 significant figures. Okay, so this is my tension at D. Now we know that tension at C plus tension at D is equal to 15G. So from this, we can find tension at C. So tension at C will be equal to 15G minus tension at D, which is nothing but 12G. So 15G minus 12G is nothing but 3G. And if you substitute the value, this will come out to be approximately 29.4 newtons. So that is our answer. So that's my A part. Okay. Now let's read further what they are saying. Now next is, when a particle of mass 9 kg is attached to the rod at F, the tension in the string at D is twice the tension in the string at C. So we have to find the distance AF. Okay, so let's make a new diagram. Now what's happening is, okay, so this is my rod AB. So this was the point C. So this is my tension at C. This is my tension at D. There was center of mass at E. So this is 15G. Now they have given that there is a point F at which a mass of 9 kg is attached. So we don't know where is F, right? So you can take anywhere, it doesn't matter, it will come out automatically. So let's take the point F to be here. It doesn't matter actually. So you can take it anywhere. So this, let's take this point as F. This is 9G means the force. Now it's given that tension at D is twice the tension at C. So what is given is tension at D is nothing but 2 times the tension at C. So this is given to us. This is given in the question. Okay. So now we have to find the distance AF. So what we can do is, let's write the equation. Now, if this rod is in equilibrium, we can say that tension at C plus tension at D will be equal to 9G plus 15G, which is 24G, right? So upward forces will be equal to downward forces because it is in equilibrium. And we know that tension at D is 2 times tension at C. So this becomes tension at C plus 2 times tension at C equals 24G. So from this, I am getting as tension at C is equal to 24G divided by 3, which is 8G. So tension at C is 8G. So automatically tension at D will be, let's change these values. This is 8G, this is 16G. Okay, so we know the tensions also. Now next is, we need to find this point F, the distance AF, right? This distance. So now you need the distance AF. So what you can do is, let's take the moment about A point. Because moment about any point, net moment about any point will be 0. So moment about A, when you take moment about A, so let's first take 8G. So this 8G, this direction will be anti-clockwise. So anti-clockwise means negative. So I will take minus 8G times, what was AC? AC is 1. Okay, so this is 1. Let's write the distance. This total was 2.5. And I think this was 2. This distance was 2. Okay. So I will get minus 8G into 1 plus. Now this 9G, moment for 9G will be 9G into 3, right? And this direction is nothing but clockwise. So plus 9g into 3. And again for 15g it is also positive because it's clockwise, so 15g into 3. Oh, this 9g we don't know actually the distance. We have to find this distance, right? So let's take this distance we have taken already this as x. So let's take this as x. And then for 16g, this is my force. And if you take this, this will be anti-clockwise. Anti-clockwise means negative. So minus 16g times, what is AD? AD distance is 3.5. So this is into 3.5 equals to 0. So net moment will be 0. So let's find the value of x. So we will take x on one side and take everything on the other side. So we will get 8g plus 16g times 3.5 minus 45g. So from this we are getting 1648.56, so 970. So x will be equal to nothing but, so 16 into 3.5 is 48 plus 8, that is 56. 56 plus 8 is 64. 64 minus 45 is 19. So we are getting x as 19g divided by 9g. So we can cancel this g. It implies my distance x is nothing but 19 over 9 meters. So that is my answer. Okay. So this is how we can find the unknown distance also. I hope it's clear. Okay, let's try one more question on this center of mass concept. Okay, so this is our next question. A seesaw in a playground consists of a beam of length 10 meter. Okay, so two persons are there, Sophia and Roshan. Sophia has mass 30 and Roshan has mass 50. This is x. Okay, the beam is initially modeled as uniform rod. Now this is important, huh? Uniform. It means center of mass will be exactly at the center. Now using this model, find the value of x for which the seesaw can rest in equilibrium. Okay, so let's first do this. So now for this, what we can do is we need to find this distance x. So what we can do is there will be some reaction force here. There will be some reaction force here, right? So what we can do is we can take the moment about C. So we can take moment about C. So moment about C. Now why you are taking moment about C is because so moment of reaction force will be 0. So you don't have to calculate the reaction force. So that's the purpose of this. What's the weight of Roshan is 50g and this is nothing but 30g. Okay, so this is 30g. This is 50g. Okay, so my answer will be, so let's first find for 30. So 30 into this will be clockwise direction, right? So it will be positive. So 30g into 5, right? Because C is at center. Now when C is at center, so it means this will be 5 meters. So 30g into 5, that is clockwise, or that is anti-clockwise, plus 50g into this. So this will be clockwise. So plus 50g into x. So this should be 0. So from this, I am getting my x value as 150g divided by 50g, right? Which is nothing but 5. Sorry, which is nothing but 3. So 150 over 5 is 3. So x is 3 meters. So basically, initially the Roshan is sitting at a distance of 3 meters from C. That's my A part. The second part is state what is implied by the modeling assumption that the beam is uniform. Okay, so when we assume that beam is uniform, is we know this, right? We discussed this. When we assume beam is uniform, it means center of mass will exactly act at the center. So that's why when you take moment about this point C, which is at center, so moment for weight, that is mg, will be 0. So we don't have to consider the weight of the rod while calculating the moment, because we know it is at the center, so moment will be 0. Okay, so Roshan finds that he must sit at a distance of 4 meters from C for the seesaw to rest horizontally in equilibrium. The beam is now modeled as non-uniform rod of mass 25. Okay. Find the distance of center of mass of the beam. Okay. So now next part is basically what they are saying is, instead, okay, so let's make a new diagram. So now what's happening is, we know this distance is 4 meters. So Roshan is sitting at a distance of 4 meters from center, and the mass of the beam is 25 kg, but we don't know where the center of mass is. So actually we have to find that. So let's take that center of mass is somewhere here at a distance of x from C. Okay. So there will be a reaction force here, correct? So let's take the reaction force as R. Now these are all my forces. So there will be 4 forces: weight of Sophia, weight of Roshan, weight of rod, and there will be one reaction force. So let's try to calculate everything now. So we need to find basically x in this. Where is center of mass? So let's try this question now. Okay, so first equation that we can make in this is, if you take again same thing, if you take the moment about C, so what will happen is, then you don't have to calculate R, because then moment of R reaction force will be 0 and you don't have to calculate R. If you take at some other point, then you will have to calculate the value of R. Okay, so I think you understand this. So taking moment, again the same thing, taking the moment about C. Let's write the equation. So if you take the moment about C, so for 30 kg, this will be again anti-clockwise. So 30 into 5, 30 g into 5, that is again anti-clockwise. Plus, or for 25 kg, again it will be anti-clockwise direction, right? As you can see, this is 25 kg, this direction is anti-clockwise. So anti-clockwise means negative. So minus 25g into perpendicular distance, that is x, that we have assumed. For r it's 0, you don't have to write. And for 50g, this will be clockwise moment, right? So clockwise moment means plus 50g into 4. So this must be 0. Okay, so let's solve this. This is 150 and this is 200. So 50g minus 25g into x is equal to 0. So x is coming out to be 50g by 25g, which is nothing but 2. So x is 2 meters. So center of mass, what exactly they are asking? Find the distance of center of mass of the beam from C. So distance, it will be 2 meters. So that is our answer. I hope it's clear. So it depends on the question. Sometimes they will give you uniform rod, sometimes they will give you non-uniform. If it's non-uniform, don't assume the center of mass at center. Always assume at a distance of x from center or from the ends, so that you can calculate. I hope it's clear. So if you have any doubt, you can post in the comments and I will make sure I will answer as soon as possible. And if these videos are helping you in any way, you can share them as much as possible and like the video and subscribe the channel. Thank you so much for watching STEM Trainers.